Jai Hind students, let's start our next class. In my last video, I had explained you matrices and the types of matrices. But today, I will teach you some operations on matrices. Under this section, we will study some operations on matrices like addition of matrices, subtraction of matrices, multiplication of a matrix by a scalar, and multiplication of matrices. So are you ready for that? Yes, let's start. Under the section operation on matrices, first of all we will discuss about addition of matrices. So the very first operation is addition of matrices. So in general we can say that if A equal to Aij and B equal to Bij are two matrices of order m by n, then the sum of matrix A and matrix B is defined as a matrix C equal to Cij of order m by n, where Cij is equal to Aij plus Bij. Understood? What I am saying here, if there are two matrices, one is matrix A, its elements are in a form of Aij, and second matrix is B and its elements are in a form of Bij, are two matrices of order m by n. Please note this point. Addition of matrices are possible only when the order of both the matrices are same. Understood? If order of matrices are same, then only we can add the matrices. If order of matrices are not same, then their sum is not defined. Understood? So this is a very important point you have to keep in your mind, that the order of both the matrices must be same for addition of matrices. So there are two matrices, one is A, another is B. So the sum of A and B is defined as another matrix C whose elements will be in a form of Cij, and the order of sum of matrix will also remain same, means m by n, where Cij are the elements of that new matrix. So these elements will be in a form of Aij plus Bij. Let A matrix is A square plus B square and B square plus C square, A and B, and B matrix equal to 2AB, 2BC, B and C. Suppose that these are two matrices and we want to add them. So what we can do? So very simple. A plus B is equal to, first we have to note the A matrix. A matrix is A square plus B square, B square plus C square, A and B, plus B. Second matrix is 2AB, 2BC, B and C. Now we want to add them. So what is the method for finding the sum of matrices? We will have to add the corresponding elements of both the matrices. You understand what are the corresponding elements? Yes. So very first element of this matrix is A square plus B square. It will be added in the first element of the second matrix, that is 2AB. So plus 2AB. Now the second element of first row of first bracket, that is B square plus C square. This will be added to the second element of first row of second bracket, that is 2BC. So plus 2BC. Now we will add the first element of second row in the first element of second row of second bracket. So that is A is added to B. Now the second element of second row of first bracket will be added to second element of second row of second bracket, that is B plus C. Now see, A square plus B square plus 2AB. What is it? It is an identity. A square plus B square plus 2AB can be written as A plus B whole square. So this can be written as A plus B whole square, and B square plus C square plus 2BC. This is the identity of B plus C whole square, that is A plus B, and this is B plus C. Now this is the sum of these two matrices. Understood? Hope you are understanding it. Any doubt is there? All clear? Okay, that's good. Now the second operation on matrices is subtraction of matrices, because this is same as addition of matrices. Let's say if A is equal to Aij and B is equal to Bij are two matrices of order m cross n, same as addition of matrices. Here also the order of the matrices should be same, then only we can find out the subtraction of matrices. Understood? Then subtraction of A and B is defined as another matrix D whose elements are in a form of Dij, and its order will also be same as the given matrices, means m by n, where Dij is equal to Aij minus Bij. The meaning of Aij minus Bij is the difference of their corresponding elements. Understood? So subtraction of matrices and addition of matrices both are nearly same. I am explaining this definition by taking up some examples. Let there is a matrix A, 2, 4, 6 and 8. The order of this matrix is 2 by 2, and another matrix B, that is -2, 3, 8 and 7. The order of this matrix is also 2 by 2. Understood? Now we have to find the subtraction of A and B. So A minus B equal to, A is 2, 4, 6, 8 minus B is -2, 3, 8 and 7. Clear? Now A minus B equals to another bracket. Now we will subtract the corresponding elements of both the brackets. Corresponding elements, the first element of first row of first bracket, first matrix, and the first element of the first row of second matrix. So the first element is 2, minus is here, so minus, and the first element of second bracket is -2. Since minus is here and this element is -2, so this minus and minus will be +2. Got it? Similarly, the second element of first row of first matrix is 4 minus second element of first row of second bracket, that is 3. Understood? Now, the first element of second row of first matrix is 6 minus first element of second row of second matrix is 8. Similarly, we will have to find out the fourth element. So the second element of first row is 8 minus second element of second row of second matrix is 7. Now simply we have to solve this. What? Now we will get 2 plus 2 is 4. 4 minus 3, 1. 6 minus 8. 6 minus 8 will give you minus 2. And 8 minus 7, that is 1. Now we have to check the order of this matrix. What is the order of this matrix? The order of this matrix is 2 by 2. Understood? So what we have to remember here? The order of both the matrices should be same for addition of matrices and subtraction of matrices. Understood? Hope it is clear to all? Good. Now the third operation on matrices is multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. So scalar, you know what is the meaning of scalar? Scalar means some constant. If we multiply a matrix by any constant, then which rule we have to follow? So let's see. If A equal to Aij of order m cross n is a matrix and K is a scalar, K is some scalar, then the multiplication of given matrix by K is defined as, multiplication of the matrix by K is defined as Ka is equal to K and the value of matrix is Aij of m cross n. Now what we will do, we will multiply all the elements of the matrix by this scalar. Are you getting what I am going to say? Because if any scalar is, if the multiplication of a matrix with any scalar, then this scalar is multiplied inside the matrix. Means every element of a matrix is multiplied by this scalar. So this K will be multiplied by Aij. So it will be Kij. Now let an example here. Let A is a matrix 2, minus 1, 3 and 4. Suppose that there is a matrix A 2, minus 1, 3, 4 and its order is 2 by 2. And we want to multiply this matrix by a scalar 3. Suppose that we have to multiply this by 3. So it will be 3A. That means 3 into 2 minus 1, 3 and 4. Now what we have to do? We have to multiply each and every element of the matrix by this scalar. Understood? We have to multiply every element of this matrix by this scalar. How? This 2 is multiplied by 3, so it will be 2 into 3. Now this minus 1 will also be multiplied by 3, so it will be minus 1 into 3. Similarly, 3 is also multiplied by 3, and the last element of this matrix is 4. This is also multiplied by 3. So now we will get a new matrix 2 into 3, that is 6, minus 1 into 3, that is minus 3, 3 into 3, that is 9, and 4 into 3, that is 12. So this is the value of 3A. Is it clear? Again I am telling you, if a matrix is multiplied by an scalar, then each and every element of that particular matrix would be multiplied by that scalar. Are you getting this? Okay. So till here I explained you how to add two matrices, how to subtract two matrices, and how to multiply a matrix by a scalar. Understood? Now we have to discuss about negative of any matrix. Clear? Okay, let's see. Now we will discuss about negative of a matrix. Students, now we will discuss about negative of a matrix. So, negative of a matrix, negative of a matrix A is equal to Aij of order m by n. Negative of a matrix A is defined as negative of a matrix means minus of A. Understood? This is negative of matrix A. So negative of a matrix A is defined as minus of A. Equal to, minus will remain same, and A is equal to this. So we have to put here Aij or m into n. Clear? Now minus A is equal to, this minus can be written as minus 1 into matrix Aij or m cross n. Is it clear to everyone? Now see, this is a matrix and this is minus 1. So this is matrix and minus 1 is considered as scalar. So this is same as the multiplication of a matrix by a scalar. So it will be minus A is equal to, if a matrix is multiplied by a scalar, then what we will do? We will multiply each and every element of that matrix by that scalar. So same, this minus 1 is multiplied in inside the matrix. So it will be minus Aij of order m by n. Clear? Okay. Consider an example. Let A is equal to minus 1, 2, 3 or minus 4. This is it. And we want to find negative of A. So beta, negative of A means minus A is equal to minus, and this matrix is minus 1, 2, 3 and minus 4. So what I told here, this minus can be written as minus 1 or matrix minus 1, 2, 3 and minus 4. Now this is a matrix and it is multiplied by a scalar. So each and every element of this matrix is multiplied by that scalar. So it will be minus A equal to minus 1 multiplied by this scalar, that is minus 1. 2 multiplied by scalar, that is minus 1. 3 multiplied by this scalar, minus 1, and this minus 4 multiplied by scalar, that is minus 1. So minus A equal to negative 1 into negative 1, it will be positive 1. 2 into minus 1, that is minus 2. 3 into minus 1, this will be minus 3, and minus 4 into minus 1 gives you 4. 4 ones are 4. So this matrix will be defined as the negative of matrix A. Understood? Hope it is clear to everyone. Good. Students, now we will discuss about some properties of matrix addition. These are the properties of matrix addition. The addition of matrix satisfy these 4 laws. The very first law is commutative law. You know very well commutative law. So here the properties of matrix addition, the commutative law is कि if A and B are two matrices of same order. If A and B are two matrices of same order, then the sum of A and B must be equal to the sum of B and A. Means the result will remain same. Order of the matrices doesn't matter. A plus B is equal to B plus A. This is commutative law. So if A and B are two matrices of same order, then the sum of A and B equals to the sum of B and A. This is commutative law, and the addition of matrices satisfy commutative law. Got it? Okay. Now the second is associative law. Again, we all know about the associative law, but for matrices, the addition of matrices, if there are three matrices A, B and C, and these three matrices are of same order, then the sum of A plus B, then the sum of A and B, and the sum of C, yani A plus B in a bracket plus C is equal to A plus B plus C in a bracket. This is also same as commutative law. The addition will remain same. The order of the matrices doesn't matter here. Understood? So addition of matrices satisfy commutative law as well as associative law. Understood? Now, the third property is existence of additive identity. Existence of additive identity. If A be a matrix of order m by n and O be a zero matrix. Zero matrix, you know, a matrix whose all the elements are zero of same order. If A be a matrix of order m by n and O be a zero matrix of same order, means of order m by n, then the sum of A matrix and zero matrix equals to the sum of zero matrix and that matrix. See this, A plus O equal to O plus A. This is commutative law or not? In place of B there is O matrix. So A plus B is equal to B plus A. Addition of matrix satisfies the commutative law. So same here, if A is any matrix of order m by n and O be a zero matrix of the same order m by n, then the sum of A and O equals to the sum of O and A gives us A. The sum of these two matrices is equal to the matrix A, because O matrix and a zero matrix, all the elements are zero. Then the sum of zero and any element will give the same element. So we will get the same matrix A. So A plus O equal to O plus A equal to A. Then we can say that zero matrix is called additive identity for matrix addition. Understood? If A is a matrix of order m by n and O is a zero matrix of the same order m by n, then by the commutative law, the sum of A and O equals to the sum of O and A equals to, we will get the original matrix A. Then we can say that zero matrix is additive identity for matrix addition. Understood? Okay. Now the next is the existence of additive inverse. The existence of additive inverse. Let A be a matrix of any order. Let A be the matrix of order m by n. Then we have another matrix that is negative of this given matrix. If A is a matrix, given matrix, so we are having another matrix that is negative of A, such that the sum of given matrix and negative of A equals to negative of A plus A. Again, this is commutative law. In place of B, there is negative of A. So A plus B. In place of B, there is negative of A. A plus negative of A is equal to negative A plus A. That gives you zero matrix. Understood? So if there is a matrix A of order m by n, then another matrix is negative of A of the same order, then their sum gives us a zero matrix. Then we can say that negative of A is additive inverse of A. Clear? If the sum of any matrix and its negative matrix gives you a zero matrix, then negative of A is called additive inverse of A matrix. Understood? Good. Okay, students. Now I am going to wind up this video. After this video, I will provide you one assignment based on today's topics, and you have to prepare the notes on the topics which I have discussed now, and you have to solve the given assignment. We will meet again and we will discuss the remaining topics in the next video. Till that time, take care and bye.